Okay, and then we can make a start. Okay, so welcome to today's presentation. My name is Nigel Watts. I'm joined today by Mustafa Tumurtan. Mustafa is the product manager of ProtaSoftware. He's based in Ankara in Turkey. I'm based in Kuala Lumpur in Malaysia, and today we are joined also by our distributors in India, CAS Group, who have kindly organised this presentation to you all. To start with, I'm just going to give you some quick background on today's agenda. I'm just going to give you some quick insight into the Prota Group, just a very quick overview just to set the scene. I'm then going to be joined by Mustafa, who's going to talk about the development of the Indian code and the journey that we've been on in terms of creating this fantastic new capability to the Indian standards and a lot of the journey that's involved. And then I'm going to take you through the software. We're going to do a live presentation. I'm going to take you through and show you how ProtaStructure works, give you an all-action preview of the 2025. So Prota is a global company. We have offices in Malaysia, Singapore, across Turkey, and in Poland. And we have a distribution network that's expanding across the globe now. Recently, we've been expanding significantly across, in particular, Southeast Asia. So we're supporting, getting on for about 700-800 companies in this part of the world. Globally, we're supporting about 5,000 companies using the technology. And it's been very exciting recently in that we're now fully supporting or provide comprehensive support to the Indian standards. Now, just some background on Prota. It first started commercial versions of what was previously Orion back in 1992. And in the beginning, that was the world's first design and detailing system for reinforced concrete structures. We've also been involved a lot with retrofit and rehabilitation. So in 2005, we introduced technologies to aid engineers who wanted to look at upgrading existing infrastructure. So assess buildings and plan out retrofit to ensure that they meet modern earthquake standards. We started communicating with Revit. We were one of the first to have true physical bidirectional model exchanges with Revit back in 2007. And so we've always been trying to innovate and create technology that is leading, class leading. In 2014, we introduced ProtaStructure, and this is where we re-engineered the system and created a true multi-material platform for concrete and steel building design and detailing. Not to be outdone, Prota's engineering teams have also been involved with some world's firsts. So we designed the world's largest airport terminal building in ProtaStructure in 2018. That's the new Grand Airport in Istanbul. And we're now supporting or distributing the software to almost 95 countries around the world. So we're growing very quickly. It's in a very exciting time to be with Prota. Now, to do this, we have over 40 years of experience in developing the technology. This includes language support, multi-language support, significant numbers of design guides to explain new features, and you'll see that we've written a lot of design guides to the Indian standards as well. And we support a range of international codes. So formerly the British standards, the Euro codes, the American standards, and also a lot of subsets of those. So a lot of local national annexes to places like Malaysia and Ireland and Singapore, and other places where they use American codes where they have subsets of those. So for example, in Thailand and Indonesia and the Philippines and the like. But more recently we've also introduced the Indian standards into the software, which is what we're going to focus on in today's presentation. Now, just some background and kind of what makes us unique is that we've been looking at how engineers typically work, and When we look across industry, we see that there's lots of people using modeling and analysis programs. So there's loads of different software out there. You'd know of ETABS and STAD and so on. And these do some design, but they tend to just do basic elemental design. So they're doing things like basic checks for to size up sections, but often they're missing a lot of the details. So they're not checking things like lap lengths and anchorage and the arrangement of bars for constructability and things like connection design. So there's a lot of things that are getting missed. So often you're using little component design to help with this, and maybe you're using programs like Procon or LimCon or other tools to complement this process. And then when it comes to drafting, you're often using generic CAD tools to help you with this. So maybe you're using AutoCAD or G-StarCAD or ZWCAD. There's lots of different CAD programs out there, but they tend to be generic. They're not specifically set up for structural detailing in the way in which structural engineers would produce and create their drawings and organize things. And then if you need to go to fabrication, again, there's a different tool set here. So you've got BoCAD, you've got Advanced Steel from Autodesk, you've got Tekla Structures and the like. So again, there's a range of different tool sets with different interfaces that you'd need to invest in. And then finally, if you're wanting to get into BIM, you've got different BIM platforms, the main one being Revit, but there's programs like ArchiCAD and so on that are BIM technologies that you may want to share and communicate and interface with. So when we look across most offices, we see a collection of different tools that people are using. So they may be using their STAD, and they've got ETABS, and they've got little things for connection design, Procon, LimCon. Maybe they've got AutoCAD, and they've got Revit. So they've bought a range of different tools. And what we see is that a lot of these tools have got different interfaces. There's different aspects of having to learn all these different programs and the time taken to do that. Naturally, there's also the investment involved. So it's quite significant investments that people are making in the technology that they're having to acquire. But what we also see is that a lot of these programs don't communicate to one another. So a lot of the information is trapped in silos. So you've done your modeling and design, then you've got to sketch these up and pass them to a draftsman to draw up. You've then got to build a separate BIM model to allow you to coordinate with the architect and other team members. So we find that this whole process is extremely disjointed. So what we've done is gone away and think there must be a better way to work. There must be a better way to deliver projects. And what we've done is created a streamlined system for building modeling and analysis, so dedicated for building structures. We can then design everything from the roof down to the foundation, and giving special treatment for things like flat slab systems, shear wall systems, core walls, ductile design, detailing, foundations, everything that you'd need to do to complete the design of a building. Then we've created a dedicated platform that allows us to share and create and share our detailing. So ranging everything into CAD with all the tools available of CAD to allow you to organize things, but a dedicated platform to allow you to organize and manage and create all your drawings at the click of a button. But also providing you with all the flexibility of CAD so that if you want to make changes and adapt things, you can, as well as add other little components that you may have in jobs, things like retaining walls and other little areas that you may need to complement the design with. You may also wish to go down to fabrication. So maybe you're working with on a design build project, or maybe you're working with a contractor and they want that extra level of information to help them facilitate construction. So being able to actually go right down to producing shop detailing, rebar schedules, steelwork detailing, to go right down to the nuts and bolts as required. And then finally, a tool that allows us to share and communicate with other project team members, whether it's the architect, the owner, to be able to share this information across platform in a seamless way. So this is the philosophy behind ProtaStructure. It's just one system, streamlined for building design and detailing, and combines a few subcomponents. So we have ProtaStructure, which is the main sort of modeling, design, analysis, design, and documentation part of the software. That's complemented with ProtaDetails, which allows us to create all of our reinforced concrete detailing and general arrangement drawings. We have ProtaSteel, which can work with the steelwork and look at the connection design and detailing down to steelwork fabrication. And finally, we have ProtaBIM, which is really a collection of interfaces that allow us to share and communicate the models with other programs out there. You might want to send a model out to, say, ETABS. Perhaps you want to communicate through Revit and you want to bidirectionally link with Revit. Perhaps you'd like to create all your documentation. So there's a collection of tools in there that allow that to take place. Now, the software is being used all over the world. We've got some really amazing projects that we see our clients getting involved with, a range of different interesting projects that we see, from airports to large commercial infrastructural projects, educational, healthcare, multi-story mixed-use developments, hospitals, buildings all over the world, concrete, steelwork. It really is an interesting mix of structures that we see, seismic focused buildings, airport structures, even down into sort of industrial structures, steelwork, stadiums, overpasses and the like. But the whole system is really driven around productivity. So we're trying to streamline processes and really make you significantly more productive in the way that you deliver your projects. And time again, we're seeing across the world that we're able to save engineers significant time with how they go about delivering their projects. So at this point, I wanted to draw Mustafa Tan in. So Mustafa is the product manager for ProtaStructure. And I wanted to just sort of introduce Mustafa, but also we want to talk a little bit about the implementation of the software to the Indian codes. Are you there, Mustafa?
Hi, Nigel. Yes, I'm here. It's a great pleasure to speak here today. So I hope everyone is okay too.
Yep.
So you already gave the introduction about me. So I'm Mustafa
Yep.
Tan and product manager at ProtaSoftware. So
yeah. So obviously, Mustafa, we've done a lot of work over the last year or so in implementing the Indian codes. It's quite a comprehensive implementation, isn't it? We've covered a lot of ground, and we've really gone almost from A to Z in terms of covering the code completely, isn't it? Haven't we?
Yeah, yes. In fact, because of the nature of ProtaStructure, we have a lot, of course, to implement, because we are not stopping at analysis or modeling. First of all, we have to automate the load combinations, etc. We have to calculate the base shear, but it's not all about it. We have to continue with design and detailing, and there are a lot of details to the Indian code. So we have to take care of all of them. It was a very intensive work, but finally we managed to put all the stuff in ProtaStructure.
Yep, that's right. So today we're just going to talk a little bit through some slides just to introduce people into what this is all about. Obviously, at the beginning, we've got these templates that we use, right?
Yes. Since ProtaStructure is a design software, design and detailing software, of course, we have a lot of settings around the country practice and the design codes and the seismic codes that we are using. So what we did, we collected all of these settings and practices, detailing practices, design practices, in a setting, and we created templates. So when you start a project, you just select the template, and it will make your life easy to kickstart your model. So you don't have to deal with each and every setting to fine tune it. So all the best practices, all the best settings are already packed with templates. But of course, you can create your own templates. So that doesn't mean that you are stuck with what we give to you. You can fine tune the settings, adjust your materials, all the design parameters, and create your own template. And you can continue with your template as well.
That's right. And these can be, we've created templates for all over the world. So if you are maybe based in India, but you're doing work elsewhere, there's lots of templates that cover, maybe you're doing work out of Singapore, or perhaps you're doing some work out of the States. There's templates that cover all of that, aren't there, Mustafa?
Yes, definitely, that's correct. So it's a very very practical way of creating a project for any practice around the world.
So the load combination generation is interesting, isn't it? And obviously you can see the codes there as well. Maybe.
Yeah, you're right, because that comprises of one of the major features of ProtaStructure. So we support a wide range of international RC design, steel design, composite design, wind and seismic loads. So of course we have all the IS Indian codes in the software now, and also the load combinations are generated automatically in ProtaStructure. We have an interactive wizard for that purpose. You can choose options, for example, for vertical and lateral load cases, such as pattern loading, construction stage, P delta effects, response spectrum analysis, or equivalent static analysis, vertical earthquake effects with static and model approach. You can use cracked sections and so on. And all the necessary load combinations and load cases will be automatically created, complying with the Indian standards. That's the beauty of it. So
Yep.
once you select the Indian codes, all the load combinations, including what I mentioned, will be created automatically with the correct load factors.
Yep.
Of course, you can further edit the combination factors, that these are not static. You can edit them to suit your needs.
Yeah, and this is all done with a few clicks, isn't it? It's very quick to set up, as people will see shortly. So just moving on then, we've also done a lot of customization work to suit local requirements. So wind's part of that, isn't it?
Yes, in ProtaStructure we have a very powerful wind loading calculator, and and the wind loads are also calculated, of course, according to the IS 875 wind loading code. All you have to do is to launch the wind load generator and specify the necessary parameters, such as basic wind speeds, minimum wind pressure, directionality factor, structure type, and terrain category, etc. And then ProtaStructure will calculate the wind loads for each of the load cases in X and Y directions, and even with negative reversed directions. And these wind loads will be assigned to the story levels. And
Yep.
also, besides, you can also import the wind loads from an Excel spreadsheet if you have it.
Yep, that's right. So it's really simple, isn't it? It's just a few clicks, and it takes you through the code step by step, and then you can create all of these automatically. Seismic's obviously very important, especially in parts of India. It dominates the design. We've done a lot of work in this area, haven't we?
Yes, to admit, seismic analysis and design is one of the strengths of ProtaStructure. We have implemented features that are, I can say confidently, that's not existing in any other software. You cannot find the automations that we provide you in any other software. So we have a comprehensive user interface, first of all, for calculating the acceleration spectra. So the starting point is the spectrum, and you can create this, automatically create the spectrum using the parameters outlined in IS 1893. So for example, all you have to do is select a town in India, the related seismic zone, and other factors will be fetched automatically from the code. And we provide you the helper tables also that are in the code, and we provide you with relevant references, so you are not also lost in the code, and you are able to track what we are doing. And also you can select different structural systems in each orthogonal direction. You can go back one, yeah. You can also select different structural systems in each orthogonal directions, and you can use different behavior factors. And of course, you can use different design spectra in different directions.
Yeah.
Yeah, and also, if you have if you have to carry out a site-specific study for a project, you can also use your user-defined spectrum. You can introduce user-defined spectra and use it in the design.
Yeah. So this is fully flexible, isn't it? It's adaptable, but obviously we've customized it to suit to make it easy for you in India, wherever you are, just to choose from maps, and it will feed the data in. But this is fully customizable to suit maybe specific project requirements, isn't that right?
Automated and customizable.
Yep, that's right. So in addition, we also do a lot of underlying checks. So post-analysis checks, there's lots of checks that we're performing, isn't that right?
Yeah, you're right, because seismic analysis is not complete unless you perform irregularity checks and other seismic checks. These are very important. You cannot just stop at calculating the base shear. The post-analysis report you see here includes all the important checks related to IS 1893, again with code clause references. For example, we perform a drift-based story check. We perform vertical mass distribution checks, torsional irregularity checks, and once we detect a torsional irregularity, for example, we automatically repeat the analysis and apply the penalties. We also check whether the equivalent static method is applicable or not in the project. And also maybe you have building with a basement, so we validate the basement for you. So whether the basement story that you designate is valid or legitimate as a basement. So there are specific checks to do that. And also we perform, of course, the inter-story drift checks, prominence of second-order checks, and all important checks are in this report. So it's very detailed.
Yep, and as you say, a lot of the because it's an iterative process, I mean, a lot of the penalties are automatically applied, right? So that just takes a lot of the pain away from having to do that manually, isn't it?
Yes, in a typical software, once you calculate the base shear, you have to do all the irregularity checks by yourself, and these can be really rigorous and time-consuming. I can say that. Also, there are, of course, some details about the base shear calculation and the modeling approach you use when you are calculating the base shear. For example, diaphragms, rigid diaphragms or flexible diaphragms, how you distribute mass. So there are details also on top of that.
Yep. And this all comes together not just in terms of the analysis, but also the design, right?
Yes. After we do the building checks, we go member by member and design the reinforcements, for example, for the beams under the envelope actions of all seismic loads. But again, seismic design will not allow us to use the analysis results. For example, if you are designing a ductile beam, you have to use the capacity shear, for example, and all the minimum ratios, the maximum ratios, or the constructive rules are changing, are overridden by the seismic codes. You cannot just go with the design code. You have to comply with the seismic code. So all the design rules outlined in the Indian seismic code is applied for the beams. Also for the columns in the next slides.
I'll just point out here that obviously parts of India may be very low, and you may not be designing for ductile detailing, or maybe it's just typical elastic gravity-based design. So that's no problem at all. But what we're doing here with the seismic goes above and beyond what you would do for say typical gravity-based structures. And this also complies with the reporting, right? You can see this not just with the design, but right through into the detailed reports, right?
Yes, because the transparency and transparent design documentation is #1 priority for us. So we have been investing in it for a very long time. We have been spending a lot of time. So when you design a member in ProtaStructure, it can be a seismic design or a gravity design. When you get the design report, you will have all the step-by-step calculations with code references and clauses outlined. So you will be able to verify or double check or track the calculations in ProtaStructure with confidence.
Yeah. And this not just for the beams, but also the columns. So obviously, columns and walls are important elements, and they're treated in a very rigorous way, aren't they?
Yes. First of all, for the columns, we perform a biaxial design. Whether it is a seismic design or not, it doesn't matter. We perform a biaxial design. But when it comes to ductile design, what we do is we, of course, apply the reinforcement ratios and constructive rules for the columns that are outlined in the seismic code. For the walls, especially for the walls, we have to consider the end zones. So the end zones are automatically considered in ProtaStructure, and also the confinement plastic zones, or each code has different terminology for it. You can call it confinement zone or plastic hinge zone or prohibited zone for columns, and for beams, of course. These are all calculated automatically, and the amount of links are provided accordingly. And for the walls, especially within the critical height or outside the critical height, we can adjust the end zone lengths, and we can calculate and shear force or bending moment envelope for the ductile wall design. And also one important thing, the section design of columns. So for the section design, you have to provide a proper containment of the concrete core. So you can use a single link with tie bars, or you can use double link. You can use diamond links, triple links, depending on the confinement requirements. So these are all automated in the software.
Yep. So obviously, the documentation is key around this as well, and there's detailed documentation covering the seismic requirements also.
Yes, especially the shear design needs some elaboration in the reports, because, as I said, we have capacity shears calculated, we have contribution from concrete under specific conditions, and etc. There are some details on that. We put that on the report step by step also.
Yep. Okay. So as I mentioned, the reporting is important, and we've provided detailed step-by-step calculations. That applies for the majority of the design, doesn't it? So it's not just the concrete work; it's also the steel work and other parts of the system.
Yes, because we support IS 875, I think the steel code, Indian steel code. So you can, of course, design the steel members. And at the end of the design, we provide step-by-step detailed reports. So the step-by-step reports are the de facto standards in ProtaStructure. For each member, you get a detailed report.
Yeah, of course, you don't need to print all these out, right? These can be summarized. So there's summary reports, and you can choose, just selectively choose if you want to provide comprehensive documentation for some critical members, right?
Yeah, of course, it can be thousands of pages if you are attempting to print out all the detailed reports. So for that purpose, we also provide summary reports. So when you submit your project, you can use the summary reports. But if you want to do spot check or one or two members, you can, of course, get the detailed reports.
Yep. We've been expanding the capability of ProtaStructure, right? And so we now have a composite design. Just for the Indian users, we're aware that you do design this to Eurocode, and this is going to be available, I think, in the next update. You'll be able to select a composite design as well. But this is just one of those aspects where we're just continually expanding the scope of what the type of design systems that we are incorporating into ProtaStructure, right?
Yes, in fact, the composite design in ProtaStructure is quite powerful. I don't want to start talking about it in detail because it will take 1 hour maybe, because there are a lot of details like composite action or stud calculation, whether it is uniform or segmented layout, vibration checks, etc. So there are a lot of details in it, but you can benefit from the composite design in ProtaStructure, of course.
Yep. And the key, I think the real key with what we do is we automate the drawing production, right? It's all about streamlining design and detailing processes, and this carries through to in the Indian standards as well.
Yes, especially in Proto Details, with one click, you can create all the structural details. Once you finish your design in ProtaStructure, you can just create all the details with one click in Proto Details. And that detail drawings includes all the seismic provisions. So, for example, lap splices in the middle or at the supports for the columns. All the link plastic hinge zones are confined with links, and span regions are maybe confined with different link spacing. We automatically calculate all the anchorage and lap splice lengths according to the code. If you have narrowing columns or slanted columns, all the bars are cranked and put automatically there. So the detailing also as includes as many details as we have in the design. So that's a very important part. I think detailing takes maybe the most effort in a project submission. So we automate it and we knew ours.
That's right. To be able to just convey all this just in a click, and just to save hundreds and hundreds of hours in terms of production is very powerful, isn't it?
Definitely.
So that extends to all throughout, right, and even down to core wall detailing. And there's different options for this as well.
Yes, shear walls are especially important because they help us to reduce the lateral displacements, and if you are and they provide strength to the structure, of course. But if you do not detail them correctly, you can have serious damages in the building. And for that purpose, especially in Turkey, we experienced a lot of damages for the walls that are not detailed properly. So for that purpose, we have comprehensive options for how the web bars will go into the end zones, how the links in the end zones will be detailed, and how the boundary elements or the end zones will be detailed, what will be the lengths, etc. So we have put all that know-how and all that experience in ProtaStructure. So again, with one click, you will get all the seismic details of shear walls there. So it can be a narrowing, it can be a basement wall at the bottom and earthquake wall through the top stories. So it doesn't matter. You will have the details.
Yep. And there's some real smart tools now in terms of sort of driving the detailing process, especially with things like automated containment.
Yes, rectangular walls we do, and also the core walls are an important part of, especially the high-rise structures. So core walls are no exception to seismic detailing. So you have to detail them also against seismic forces. So the most important part is the end zones at the intersection of the core wall flange. So that's what we do. We automate it for you. With one click, you can designate the ratio of the end zones and ratio of the reinforcement inside the end zones, and ProtaStructure will put the rebars for you automatically. And also we have an interactive wall editor that you can, for example, put the bars automatically with end zones and web bars, and you can even fine-tune the reinforcement. You can insert additional links, additional tie bars. You can change the diameters and make it ready for the design check and detailing.
Yeah, it's very customizable. It's a great new feature that's been introduced recently. Obviously the seismic design process, I know it's a theme here today, but we know that in the north of India, this is something that you need to look at carefully. Other parts of India, perhaps not so much, but there are a lot of detail behind all the checks that we do. So things like strong column and joint shear checks are important, aren't they? And they're automated.
Yes, they are automated. Especially these two checks are very, very important if you are designing a ductile building. So, and these two checks are have to be done after the design. You have to know the reinforcement inside the column and inside the beam. And these two checks especially have the potential to roll you back to the square one, because these are not satisfied, you may need to change your reinforcement, change your design, or
Yep.
change your sections, even change your structural system. So
Yep.
they are very important, and they are very hard to do by hand. So these are all automated. You can check it during the design or after the design, and ProtaStructure will give you the warnings at all step of the way. So you can fine tune these projects by looking at these checks.
Yep. So it's not just, I mean, I know that we've talked a bit about the RC, but it's just not this, is it? There's other capabilities in the software that we're just simply not going to be able to get to today. So the BIM integration that we have is very powerful, isn't it? We're able to interface with a wide range of other different systems.
Yes, because our philosophy is while we are developing the software, we are always thinking BIM first. So that's our mindset. What we do is we always try to think whether what we do is compatible with BIM practices and BIM data structures. So that's why we have a very flexible BIM system. First of all, we have bidirectional links with Revit, Autodesk Revit, so you can send the model and get the model in. You can do a round tripping. We send all the physical details, and also we support IFC 2 and IFC 4.
Yep.
So IFC 4 is a new addition to the software. It provides a better coordination, and it provides more object types. Of course, we have less intelligent types like DXF and DWG. But if you have, for example, an architectural plan in DXF format, you can just import it into ProtaStructure and create the physical members instantly. So that's also possible.
Yeah.
And also we have analysis links with ETABS and SAP 2000 on OpenSeas.
Yeah.
So you can just send the analysis model and check the results or see the results there if you need to. But
Yeah.
and OpenSeas, I have to open an important parenthesis to OpenSeas, because in ProtaStructure we have a performance-based design and assessment capabilities like nonlinear pushover, single mode or multi-mode pushover, or nonlinear time history analysis. We all perform this with OpenSeas integration. So what we do, we prepare the data for OpenSeas. We prepare all the nonlinearities, material nonlinearities, and all the parameters, and we send it to OpenSeas automatically, and we get the results back again automatically and process them. And at the end of this automated process, we generate an assessment report or performance report. That's really valuable. We are currently working on to complete the U.S. codes assessment according to U.S. codes. And also, if you have isolated buildings, seismically isolated buildings, you can also design them in ProtaStructure. We have very powerful tools. For example, you can perform a nonlinear time history analysis with isolators, so you can do a final design of the isolated buildings.
Okay.
Again, this would take maybe 2 hours to talk about, but in a nutshell, I can say that we have all these features.
Yep. And then it extends into steel design and detailing, right down to foundations, doesn't it?
Yes, foundations, of course, is an important part in ProtaStructure. We do, I'm sure you will show it. We do pad footing, pile caps, raft foundations with finite elements or analytical methods. But also what we do, we send the model to ProtaSteel. So once we finish the design in ProtaStructure, we communicate the model to ProtaSteel with internal forces and all the physical properties. Then we can do the component and connection design in ProtaSteel. We have a very powerful tool, IntelliConnect, that you can design the connections with again hundreds of connections with a single click. It's a very automated and smart way to do that. Of course, connection design is an important part in ProtaStructure as well.
Yep, that's right. So, I mean, we're just really just touching on it a little bit. We can't really do the system justice just in the short time that we're going to have here today to speak to everybody. But that was really great, Mustafa. Thanks very much for giving us that insight.
The pleasure is mine. Thank you so much for
Yeah.
giving me the chance.
So thanks very much, Mustafa. Look, we're going to. I'm now at this point just going to come out of our presentation, and I'm going to actually move into the software. So if you just give me a minute, I'll just minimize my screen here. I believe that everyone can still see my screen. And I'm going to launch ProtaStructure. And what I'd like to do at this point is actually take you through the software. So I'm launching the 2025 version of ProtaStructure, and I'm going to take you through and show you this live. And I'll try and be as efficient as I can. This process is probably going to take about 30 to 40 minutes to take you through. I'm just going to do a quick demonstration of the software and show you how what we've just discussed comes together. So I'm going to create a new project, okay, and we can call this India to 2025, and you can in here you can come and choose the templates that Mustafa was talking about earlier. So if you were doing projects outside of India, you can draw upon other templates, but here I'm going to choose the Indian template, and when we select this, it will load the Indian codes of practice. So all the localized design and detailing preferences will be loaded into a template, and it will then set this up for us to start the modeling process. Now, there are different ways that this can work depending on the information that you have. So Mustafa was talking about the fact that you can import information into here. A common way of working is that people maybe just have a 2D architectural plan. You can import this into the plan view and use it as a ghost layer to model on top of. You can extrude or extract grid lines and columns and walls and stuff from those drawings if that has that relevant information, and build the models quickly. But the general environment here, you'll see across the left there's a tree. Along the top here, we've got it in a very simple ribbon format. So starting the project is here. You can then create your modeling, your loading, assign your wind and seismic load. So you can create your modeling with your steel and concrete. You can then assign loads, so whether it's seismic or wind loading. You can check things before you get into the analysis and then the design. Finally, you can then produce or create all your drawings. So whether it's your concrete detailing or steelwork detailing with Proto Details and Proto Steel. And if you wish finally to communicate with other platforms, you can. So we've laid this out logically, so it's easy to understand how this is all set out. What I'm going to do today is I'm just going to create a simple model, and I'm going to build it from scratch because I just want to show you the essence of how the system works and how efficient and quick it can be to create a model. Here I'm just keying in some grid lines. Everything I'm doing in here is live, so you're seeing it in real time. I've created a grid line arrangement here. These are dynamic, so you can work with the axes, you can make changes. So if you want to perhaps put in a grid line that's not exactly straight, maybe you've got a curved facade of the building, you could define this. You can type in a chord length to set this out. If you have grid lines which are a little bit irregular, and we often see unusual buildings or unusual facades that some of our clients are working on, you can just come in and use the grid lines to help you drive the set out. And this can be whatever funny arrangement the architect may have dreamed up. So you can just create your grid lines here to set out the basic structure. Now I'm going to work with physical objects now to create the model. So the first thing I'm going to do is create some columns. So I can just create a column by clicking and inserting it. Or if I have multiple columns, I can box around to create them. The columns can be orientated in different directions and different ways. So if I would like to place a load of columns along the curvature of that grid, whoops, let me just do that again. I've gone. If I want to just come in and create the columns along the curvature of the grid, let me just do this again. I just missed clicking the axes there too, so I can just come in and create that, and you can see that they've all been set out along that curve. Now we have libraries of standard objects within ProtaStructure, so whether you're working with concrete or steel elements, and this covers all the different steel sections in the Indian code, typical steel sections, built-up sections, cold form sections, as well as composite sections where steel encased in concrete. So you can just choose from the library here of the section that you want to work with. I'm going to create say a 500 diameter circular column. The engineering properties will be automatically calculated, and then we can use this in the model. So I can just come in and define that column. Okay, I can just grab that property there. I'll create another column here. Okay, and we can come and set that up. Okay, so we might have a few columns as I've indicated. You can use, we can also use things like grid lines to help us with sketching items in the model. So if I just wanted to use these to help define maybe the lip on a core wall, for example, I could just come in and use these kind of sketch lines to help with that. Okay, I may want to now create a wall, so I'm going to put in a wall here. It's looking at the dimensions, so it's asking you, it's the Indian code, is that too short? Did you actually want a wall there? And there's a reason why I've done this, which I'll get to in a minute. But let's just come and create this wall. I'm going to put another wall in here. I'm then going to come and create some beams. So I'm going to, I can feed in the properties of the beam that I want to work with. Okay, and then to create the beam, I can box around to put these in. Okay, like I am doing here. Okay, or I can just snap to point. So I can just put the beams in. It knows there's two spans. It's automatically created that. It's cranked that beam along the grid line, or I can just go directly. As I'm going, if I wanted to create, say, a curved member, I can just come and create this very quickly. Okay, if you have lots of members in an area, okay, so if I wanted to create multiple beams in this area here, okay, it will it will create those. I can just box around to set those out. Okay, you can also just, it understands that this wall and this beam already exists. So if I wanted to create an extra couple of beams there, I can just draw them through. I don't have to worry about overlapping. All these types of things are just taken care of by the software because we're working with a physical model. Secondary beams, you can snap to handy points, quarter point, third point, mid-span, and you can just come and create these quickly. Okay, so you can just drive them in this way. If you have a particular distance, you can, if you hit, whoops, sorry, let me do that again. If I have a particular distance, I can, and I'm mousing over, if you hit F2, you can type the exact distance in. It'll pick that point up. It also picks up handy points like the perpendicular, okay, and then you can create that member there. Okay, now you can move these around. Okay, I can just turn that message off. It's just, I can adjust these to suit the architecture. So if you didn't quite get the positioning right, you can just adapt that to suit. Okay, so you can see that hopefully here you're starting to see that this is starting to look a little bit like a key plan. Yeah, and this is all intentional. So you can see the labeling and so on has been done. That's flexible. You can change this if you wish. At this point in time, I'm going to create the slabs, but as part of this process, it's going to ask me to generate the combinations. So this is what we were talking about earlier, where we can set up our vertical load combinations, and this includes my dead and live load cases together with pattern load variations. We can look at stage construction analysis. You can assign thermal loads here. You can also generate lateral cases. So, and I'm going to create, maybe I'm going to use response spectra. You could include vertical seismic if you wish, or you can turn this off. It's entirely up to you. And you can also create wind combinations automatically in accordance with the code. If you wanted to set up soil pressure and the like, you can do this. You can generate separate combinations for steel, okay, and these can be automatically created here. And there's other permutations that you can set up in the software. So if I hit OK, just with one click, it will automatically generate all these combinations, and you can see them here for the steel and the concrete. You can manipulate the combinations, so if you don't want to take combinations out or reduce or remove combinations, you can do that as well. So if I hit OK, that's set up. Okay, and then I can come in and create the slab. So it's I can key the thickness in there. You can assign dead and live loads into this, and I can just update that. So you can see here that we've created that, and I can just run around. Maybe I've got those loadings here and here, and maybe over in here and here. Maybe it's a bedroom or something like that. These ones you can manipulate, so you can type whatever load you like, and you can also have libraries. So you can have libraries of finishes that you can draw the loading from. Okay. And you can vary the live load, and you can type it in, and you can just come around the building and create. Now, hopefully what you see as I'm doing this is that we are automating things like the distribution of the loading. So you can see the live load, the yield lines being created as I go. You can manipulate this to suit, and I can just run around and adapt this accordingly. Okay, maybe this is one, for example. Okay, so you'll see here that we've automatically worked out the yield line. Okay, and you can distribute in this manner. You can also use Finite element to distribute loads to members. So if I just click on this member, you can see that even at this point, instantly we've already distributed the load to the frame member. And this is very, very efficient. It's very economical, and this is driving efficiency in the building. Now I may want to add extra loads to this. So you can have libraries of things like brick walls, and you can set these up. So I could have maybe a 140 block wall. I want to key the height of this wall in, and then I can just click on this and assign that to the member, and that's just set up. So straight away that brick wall's been created. Okay, and we can see that on the member there. Now any of these loads, you can take them and you can copy. So I can copy loading, the brick wall loading there, for example, and I can choose other members that I would like to maybe copy that to. Sorry, let me do that one more time. So we can copy this. Okay, and I can choose. You can select members. Okay, like I'm doing here. Okay, and you can run around and just select, or you can box around to choose members. Okay, and then you can just copy and paste. So it's just an easy process here. Now we were talking earlier about core walls and so on. Now you'll notice at this point that I've actually created these walls here, and when I originally set them up, I set them up as individual panels. But what I want to do is I'm just going to just select these walls, and I'll just grab that last one there as well. And I'm going to actually take this wall, and I'm going to merge it. So this is now one singular core wall. And Mustafa was talking earlier about us having capabilities to be able to do some smart things like automate the containment of these walls. So I'm going to do that. I'm going to add in, you can choose the percentage of end zones that you want, okay, and then just with a click of the button we can prescribe an arrangement here. Now this isn't final. During the design process we will refine this. We will select the bars, but just with things like reinforcement around the corners, creating the end zones here, this whole process is being automated as part of this, as part of how we've established this. So if I'm happy with this, I can accept that, and then that gets set up in the model there. Okay. Now I've been working in 2D at this point, but what we've actually been doing is creating a 3D physical model. Okay, and you can see the 3D model here. Okay, it's a physical model, and I can work with this and manipulate it. So you can look at different views. So you can tile these in the model. You can continue to work in both 2D and 3D. An example might be that I want to continue to load the model. Maybe I'd like to put a loading along the wall to this point. I've just clicked and dragged and created that loading. Whatever you create in here, you can visualize. So as I'm going, maybe I'd like to do other things. Perhaps I want to add in an opening in the slab, okay, or perhaps I want to create maybe a set down in the slab. So I can come in and set these up, okay, and I can work with our physical model here to define these. So if I had maybe a drop in the slab, okay, you can see that physically I've created that opening, I've created that drop. If I got the position wrong, the beauty of having a physical model is I can just pick this up and reposition it to suit. So if I had to make a change, the M&E engineers told me that that's not quite in the right position, I can do that. You can do other things like add other loading to the model. So perhaps I'd like to create a plinth and I want to assign that load to the model here. I can easily come in and create that, and whatever you create here physically, you can see it in the model here. Okay. Now I may want to select this wall. Okay, you may also want to introduce things like openings in the wall. Perhaps you've got a window or a door in that shear wall that you'd like to create. So it's very flexible, and the idea is that we can just create whatever it is that you'd like to see in the model here. Now I'm going to, at this point, come in and insert some floors. Okay, and I'd like to make this building, say, 5 stories high. Okay, and then I can take this floor that we've created and we can start to generate information up. So I can copy that and replicate that up the building. Okay, so you can see very quickly I've generated up and created those additional floors there. Now the model is editable. You can make changes at any point. So if you wanted to remove elements in here, you can. If you wanted to do things like change the structural system, for example, maybe at the top here I want to delete, and it might be that I want to remove the beams. Okay, so I could just with one click take those away. Okay, and then I'm left with a flat slab at the roof level here. So it's very easy just to adapt the model to suit what it is that we would like to show. Now I could continue to work with that a little bit. So if I decided that maybe I don't want to have this this wall here, and instead I'd like to create a couple of columns. Okay, I could just come and set those up in here and create those. I could select the columns there. Oops, let me just come and grab them. Okay, and we could make changes to this. We could, if we wished, introduce maybe some drop head panels. This may be a flat slab, and we want to have some drop head panels to help us with the shear. Okay, and you can play with the extent of these panels. You can also set up patches that we can use to integrate across those panels for design. All of this can be easily done in the software, and we can just hit OK and they're set up. So physically here you can see that I've changed that model from being a conventional beam slab to having a flat slab at that top and at a higher level there. Now to design this, ultimately we will cut strips, and we can do that in here to help us with the design. I'm going to cut some strips, some finite element strips. I'm going to use the building analysis results, and I'm going to cut some integral strips across the slab. So I can cut those strips through here, and then later we will collect the forces along those strips for the design and detailing of that slab. So you can define your strips here, and I won't do the whole slab. I'll just do a couple of places just to suit. I'm just trying to give you a little bit of variety here so that you can understand the various capabilities that we have. So I've just come and set that up, and later on we'll integrate along these strips, and we will pull those out, and we will design and detail the reinforcement. Okay, so that just gives you an idea about that level here. Now I'm going to, at this point, move up to the roof. Okay, and I'll just change the view so that you can see a clearer view of the structure here. And I'm going to work with some steel work now. So I'm just going to create some columns. So you can choose from libraries here of different sections. So you may have something in mind that you would like to use. Okay, maybe I'm using a 250, something like this section here. Okay, we can just grab a section from the Indian database, and we can create some columns in here. So you can just you can click and position these in accordance with the model. Okay, and I can drag. Okay, whoops, let me just get the position right there. We can create those additional columns there. I've just set those up there like this. We also work with what we call contextual modeling. So if I wanted to, for example, I want to create maybe a truss, I can just drag between 2 points, okay, and it will preview different types of trusses that we may have. I can import from CAD, and I can also define it a little bit like STAD, where you can put nodes and so on in. But we have libraries here of standard sort of truss arrangements that you can preview and see. You can manipulate these. You can play with the number of bays. Okay, you can, underlying this, we can play with the splice positions. You can edit the members and the sizes and so on. What you can also do is you have full control over all the member fixities here. So if I want to introduce releases, maybe moment releases or axial releases to the steelwork, all of this is very flexible. You can just come and set this up, and you can accept that, and then the element gets created. Okay, now I can take this element, okay, and you can copy this, you can choose set out points, and you can just replicate that across the model. So you can choose other elements that you may want to copy that to. Sorry, let me do that again. So we can just choose a set out point, and then you can come and place that across those frames. So very quickly you can define the steelwork structure there. I'm going to work with some steel beams here as well. So again, you can choose a section, you can play with the fixities of the steel work. When you model the steel beams, I don't have to worry about just modeling one by one. You know, it knows those columns are there. It's asking me if I want to split them, I can do that. Once I've got these in, you know, maybe I want to replicate these elsewhere. So again, I can use the copy command and I can easily copy and paste these elements to other parts of the structure there. I can easily come and define these. Maybe you'd like to also set up and create things like braces. So again, you don't have to key these in. You can just choose the two elements that you'd like to provide braces for. So I can just choose those two columns there. Whoops, let me do that one more time. Okay. So I can just choose the elements that we'd like to brace, and it will preview a bracing arrangement for me. So you can have different types of braces, V braces and K braces and diagonals and the like. You can choose your preference here. Again, you can play with the section size. So maybe you'd like to have maybe a tubular section that you'd like to use. You can just define this. And if you're happy with that, you can accept it, and then the brace will get created. Okay, and now you can run around and brace other parts of the structure there, maybe that other bay there. Maybe I'd like to brace the roof. Okay, so again, it will preview bracing arrangements. These can be manipulated. You can key the number of braces that you like in, okay, and toggle and play with the physical offsets. Okay, and then if you're happy with this, then you can accept that, and then those get created. Okay, so the idea behind this is we want to be able to create these elements very, very quickly and streamline the process. So similarly with purlins, if I wanted to create some purlins in this roof, okay, I could come in and choose an arrangement. Okay, you can see that we're also modeling the sag rods, and these can be manipulated as well. You can choose the number of bays and so on that you want to create there. Okay, these can all be manipulated to sections and so on. And if you're happy with this, then you can create. Okay. Final thing I'll set up in here is let's create some girts. So I can choose to define girts here. So we can just choose those two in columns. Again, it will preview an arrangement for the girts. We can play with the spacing and the section sizes, and you can just preview it, make sure that you're happy with how that's set out, and then you can create. Okay, and I can choose to also create that across the other face here. Oops, let me do that one more time. Okay, so let's just come and choose these two columns, and then that will be set up. Okay, so very quickly you can see that we've created this model. Now the important thing about what we've done is that you can see that this is a physical model, and the way that we would set this out would be ultimately how you'd go about building it. So the purlins are sitting on top of the truss, the girts are on the face of the column. It's a proper physical model. All the concrete structures set out as if you were going to build it. Now, in addition to this, we can automate the way in which we assign loads. So things like cladding loads can be set up, and you can assign loads in here. So if I wanted to put maybe the self-weight of the cladding as a pressure, I also want to define maybe some live loading to the roof. Okay, then you can come in here and define that, and then that's automatically set up in the model. Okay, so this just gives you an idea about how you could go about establishing a quick model. I've tried to make it simple and flexible and show you a little bit of the different features in here. Once we've done this, we can then move into setting up the loading, and then finally designing the structure. So the first step would be to assign the seismic loads. And we talked earlier about being able to step through the code here. So in here you will have the maps that you can choose from for India, and you'll be able to set this up to IS 1893. You can choose the seismic zone. Okay, if you're not sure, of course, you can just come in and choose wherever you are in India. So all the different towns or nearby are there. Okay, maybe we can assume that this is in Delhi. Okay, and the seismic zone's 4. You can choose your different structural systems in different directions. So, and this will affect the design and detailing. So I may want to use maybe a structural system 4C in one direction. These are orthogonal directions, so you can have different structural systems resisting loading in different directions. You can choose this, and you'll see that the curves will adapt to suit the ductility demand. Now, this will also affect the design, and the detailing. If you wish to key in your own values in here, you can. You can also select from different ground types based on the code. So you can just, if it was a stiffer soil, you'll notice that the curve will adapt, or maybe it's medium stiff soil. And again, you can, if you've done a site-specific study, you can fill your own parameters in here as well. Now, the analysis, we will key in the number of modes that we wish to run. You can also run vertical seismic as well, if that's a consideration, and dampening and so on can be fed in here. We'll also automatically check, as Mustafa was mentioning earlier, for irregularities. These will be checked both in plan as well as in elevation. So if you have differences in stiffness and mass, significant differences in stiffness and mass, or significant torsional irregularities, these are the kinds of things we automatically check, and we will adapt the analysis results, apply the penalties, and adapt the analysis results to suit. We'll also automate strong column, weak beam checks and joint shear checks. You also have the ability to do things like scale up the response spectral results to match the equivalent static base shear, if this is what you wish to do. So there's all sorts of checks that we are doing as part of the seismic design process here. Now, similarly, we can assign the wind loadings, and Mustafa also talked that we've implemented a comprehensive wind load generator in here, and you can choose wherever you are. So again, we're Delhi. You can choose the class of structure, okay, what type of building it is. Okay, you'll just step through the code here. The terrain category, so maybe it's a sort of a fairly built-up area, okay, that you want to have. So you'll just type in these, and the factors will adjust accordingly. Of course, you can key your own factors in here as well. You can also look at a pressure coefficient. So if you want to look at internal and external pressure coefficients can also be defined. Okay, and you can come and set these up as well, and you can use various permutations can be automatically generated here. So once you've done that, we will then automatically calculate the pressures, and we will calculate the forces that need to be assigned to the structure. So I can just apply those, and they'll be set up to the model here. Okay, and if I just hit OK, then that's been set up and done. Okay. Now, before we get into the analysis and design, we can just, oops, sorry, let me just get my view back there. We can check the model. So, and these include things like being able to check things like the live loading. So it's all color coded. You can quickly check to make sure that what you've set up here is easy to understand. Superimposed dead loads, material grades, sort of column section sizes. It's all color coded, so it's easy for you to review the project before you get into the design. Okay. The analysis is a button, and I'm going to step through this process now. So I'm going to set up the building analysis model. Before I do that, I can edit things like grades of concrete and steel. So if I wanted to design a higher grade of concrete to the structure, I could do that. And you can manipulate this member by member even, but you can also have generally you can adapt this to suit. You can also do the same thing with the rebar. So if you have preferences for the size of bars that you wish to use, you can customize this to suit things here as well. Okay, so all of this is customizable, and you can just set this up to suit the project that you're working on. Now, I'm going to use rigid zones in this project. I'm also going to, I can design the beams as flanged or rectangular. If you have foundations, these can be merged with the superstructure. You can look at soil structure interaction. I'm going to mesh the walls. I can also come and choose to selectively mesh parts of the structure. So I want to create a flat slab at the 4th floor there. I'm going to mesh that, okay, and that will be now meshed in the building analysis. So you can see that that's been activated there. Okay, now the analysis is just a button, and I'm just going to run this now. And so what we're doing now is we're taking this physical model that we've created, okay, and we're now going to automate the analysis and design of it. So this is a batch process. We take the physical, we automatically create the underlying analytical model, and you remember that when I was creating the model, I was defining if things were pinned or fixed and so on. The load decompositions are automated. Okay, we understand it's underneath the physical is the analytical, and it will go through and run this. So it's quite efficient. We use a sparse solver, okay, and it will perform the various types of analyses that need to be done simultaneously. So that's actually finished. And now it's going through the process of design. So it's designing all the columns. Okay, this is a batch process, so it's just automating the selection of all the bars as we go. And it will design those core walls that we set up earlier as well. Okay, it'll grind through those. And it will also design the beams and so on. Now you'll notice that there's also some check design options here. So we recognise that on projects often there are changes that occur, okay, and you need to have the flexibility to be able to adapt to those changes. So the idea in here is that you've got a physical model. You can just change the physical model. We keep everything that you've designed before, and it will just check that against the changes that have occurred, and it will just highlight to you those elements that maybe need to be redesigned and detailed. Okay, so there's a whole process of managing changes on jobs. Okay, it's now just batch designing the beams or the reinforcements in the beams. This can be quite a tedious process manually, especially with ductile design and detailing, and looking at capacity share and iterating to try and find the right design results. So it'll just go through this process for you, and it'll try and optimize everything as it goes. It's also looking at constructability, it's looking at the spacing of the bars, it's looking at the lap lengths, it's looking at all these different processes, all these different underlying considerations are being looked at as part of this process. Okay, so a few more beams here, and then we'll run the steel design, and then we'll almost be done. Okay, so if you just give it a few more seconds and we'll be finished. Okay. Okay, so that just took a couple of minutes. Post-analysis, there's various reports that we generate, and Mustafa touched on those before, so I won't dive into that. But what I will do is just take you into the analytical model. So post-analysis, you can see the analysis results here. So you can look at the model if you want to see things like axial load. Okay, and you can see the various combinations as well as load cases here. So you can choose a permutation that you wish to look at. Okay, and you can see that this is adapting. You can see how the load's changing as you go down the column. You can look at things like your shear forces. Okay, you can see your moments. You'll notice that we're taking the moments at the face, okay, rather than center line. So I want more efficient design. So the soffit of the beam and the column at the face of the column here. Okay, we're taking advantage of rigid zones to give us more efficient design. So you can come and interrogate the model, have a look at these in more detail. If you want to look at a particular member in more detail, you can look at this more closely. So you can see the results here. You can see it for every single load combination, load case here. You can also see the envelope that we may be using for design. Okay, all of this is shown to you here. You can interrogate the model. So if I wanted to look at maybe, I want to know what the displacement is along the member from my serviceability dead plus live case, I can easily come and see that. So you can just interrogate this if you'd like to see if there's any torsion in the member. Okay, those results can be provided to you as well. So it's an easy way to be able to just interrogate the model and make sure that you're comfortable with the results. You can look at other things in here, of course. So if I'd like to see how the structure is behaving under, for example, maybe I'm interested in looking at it under seismic. So I could just get a feel for the behavior of the building there. Okay, maybe in the X or in the Y direction. Okay, we can look at that behavior. If you'd like to see the dynamics and see how it's being excitated under seismic loading, so you can come and have a look at these, and you can see different modal shapes here, and you can look at higher modes as well. Okay, we've got some. I can keep going up and looking at all the different permutations for the building there. Okay. If you also wanted to, and I'll just turn those off for a second, but you may also want to have a look at the stresses in the, and for example, in the slab. So we also have, you can also review the contours. So you can look at the contours, so you can see the contours in the walls there. You can turn them on and off. So if I didn't want to see the shear walls and I was more interested in the slab, and maybe I want to know what the shear stresses are in the slab, or perhaps I'd like to know what the local bending stresses are, in top and bottom. This will take account of wood armour effects as well. You can also see the area of steel contours here, and you can get a feel for what kind of steel requirements might be at this stage. Okay, we'll also use, and you can see we've also integrated along the strips there, so you can see strip results, and you can view these as well, and you can see the moment diagrams and so on those strips that we cut earlier for the slabs. So if you're happy with this, we can then come in and interrogate the design. So we've got the model here. You can, if you just want to quickly check the model, you can see the design status. So you can see that the majority of the members there have passed. You can see that there's one or two members that haven't quite passed in there. So this is all color coded, and you can come in and interrogate that. So if you wanted to just look at this beam in more detail, let's have a look at why. So we can see the section design here. Okay, this is iterated, so you can see it's got very, very close. In fact, you could probably argue that that's passed. Okay, it's right on the limit. Okay, and you can come in and manually adjust here, but what you can see here is that we've automatically selected all the rebar. Okay, you can see the diagrams that we would use for the design. I'll come out of this beam. I won't look at this one in particular. Let's choose a continuous member, so something like this. Okay, we can see the design. Okay, you can see that we've automatically selected the rebars here. Okay, you can look at the diagram, so you can see the envelope that we're using for design. Okay, along that member. You can also see very detailed calculations if you wish. So earlier we were talking about documentation being very important with ProtaStructure, and what we're doing in here is we're creating all this documentation. Okay, you can see detailed calculations in here. All the detail that you'd ever need to satisfy the design is being provided here. Step-by-step calculations with reference to the code. You can look at particular parts of it. So maybe you're interested in the deflection checks that we're doing, okay, or maybe you're interested in the underlying seismic checks that we're performing for capacity share. Okay, so all of these are clearly documented. You can see exactly how we've come out with the design results. These calculations can be PDF'd or sent to Word, but they will fall into the report manager, which we can compile at the end. Okay. Now, if you just want to get a little preview, this is just a teaser of what the detailing might look like. You can just get an idea of what we might end up producing here before you actually go and create and send those out to Prota Details. Okay. Now, the design results are also collected, so you can see the design results. So if I want to look at all the columns, all these have been designed. Okay, I can click on a particular column. We can look at the design in more detail. You can see which case is critical. So this is the critical combination that's governing the design. We will work out the exact location of the neutral axis to work out capacities, and you can see your interaction diagrams here with the capacity plots. Okay, this is all being done to the code. And again, you can also see detailed reports. So if I just create the report, you'll see that you've got detailed calculations in here, and this also includes all the capacity share checks that we're doing to the appropriate clauses in the code. Okay. Now, underneath this, there's also joint share checks that we're performing. So if you click on and strong column, weak checks that can be created. So again, these can be documented, and you can see the various checks there. Okay, I think I need to probably run that for a beam rather than a column. Similarly with the story beams, again, we can see the design here. I think I've got one other member that I need to just quickly update, so we could just change the rebar. I think that was the same as the earlier one, so let's just get this right. Okay, so we can see the design there. We might be satisfied with that. What you can also do is you can group members, so you can group all similar axes. So it will rationalize the design. So instead of me getting hundreds of beam details, it will rationalize this, and you will just get a grouped arrangement of bars there. Okay, so I'm happy with that. Okay, similarly, you can look at the steel design and you can interrogate this. So again, you can select the elements, or you can dive in and look at the detail here, and you can see the detailed checks. Okay, and there are also detailed reports that you can review, and again, all the clauses, code clause referencing and so on is being provided here. Okay, so all of this is being documented. It's very clear and easy to understand how we've come up with the design. Okay, and you can just come in and view this. Now, I'm going to move down to a different level. I'm going to come down to the foundations now, and if I come and select these columns on the edge, okay, and I'll just come and just choose a few, something like those. And if I right click, I can now come in and put in a pad base or maybe pile caps. So let's just put in some pile caps. Let's create these, okay, and you can see pile caps design. You can set up the allowable working loads and so on can be established, but I'm just going to come and batch design these. So all the pile caps are designed. Again, I can group these, so it will find those that are similar. Okay, and it'll rationalize the design here. And if I hit OK, you can see just with a click, we've been able to come in and design the pile caps. Okay, now each pile cap has got flexibility, so you can come and work with the piles. So if you find on site piles move, okay, and you want to check for eccentricities, then you can key in the exact location of the pile and we will check the as-builts. Okay, so you can just customize this and you can actually get the actual as-built locations of all of these. Similarly with the pad bases, if you just come and select these other columns here, let me just choose this one. Okay, if I right click, I can insert a pad footing. Okay, and these can also be automatically designed. So we can just design all of these. They'll be designed in a batch process and they're done. Okay. Now, if you have other foundation systems, so for example, I may want to put in a raft. Maybe I've got a raft beneath the core wall there. We can define the raft. You can key in the thickness in here, and you can assign that in here. Now, if this raft didn't work for some reason, maybe you find that the bearing pressures are too high, you could insert piles beneath this as well. So you can have piled rafts, or and you can play with various arrangements in here. You can arrange them accordingly. You can delete and remove piles. It's up to you. But we support a range of different foundation systems in here. Okay, and here you can visualize all of this as well, so you can see exactly what we've been up to. Okay. The final thing I might just want to have a quick look at is go back up to the 4th level and we see if we can just look at the design of the slabs. So, oops, let me just design. Okay, I've probably got to play with this a little bit. I'll come back to it. So I've got my building, and maybe at this point I'm largely complete with the design. Now at this stage, I want to start to document. So I want to come and take all of this and create all of our drawings. So I'm going to, at this point, come out to ProtaDetails, and we're now going to start to produce. So we've done our design, we've completed our design, we're happy with everything. We now want to start to document out the project. So I've completed a little model here, and at this point I'm going to launch ProtaDetails. And as Mustafa mentioned earlier, ProtaDetails is a complete CAD system, okay, and this allows you to fully automate the documentation of the model. Now to do this, we can just ask it to auto-generate. I can click on this. I can see all the different elements that we want to draw. I'm going to insert this into a sheet, and this would be your standard title block. So you can come in and input your standard title block. You can label them however you want. Okay, you can put in the scale of the details and various details in here you can manipulate. If you want to change the way, for example, beams are truncated within the drawings, all this can be done. Once you're happy with this, you can just ask it to draw. So what it's going to do now is take all that design information that we've done, okay, and automatically come in and create the documentation for us. So you might just see that it's put in a little sheet outline, and we're now going to go through and very quickly, and it's going to start to document things for us. Okay, so just give it a few more seconds and you'll see this come to life. And this is really where the magic happens in the software. Okay, this is where we really start to save you significant amounts of time with documentation. Okay, so it's almost done. Okay, it's just finished. Okay, you can see there that here we've got our foundation drawing. But if I just come out, you can see that just within a click, we've created all these drawings, all automated, all within a click. Okay, and you can come in here, you can see our foundation drawings. Okay, you can look at your key plans. Okay, you can see this would be your title block. Everything's laid out into this. You can also see set out drawings against grid if this is what you would like to show. You can see the detailing in the core walls there. Okay, you can see our elevations of drawings, so you can see elevations of our shear walls. You can also see the column design. You can see all the ductile detailing being employed as part of that as well. Okay. If I come over to the beams, if I come over, you can also produce things in schedules. So column schedules will be created. We'll automatically group similar elements. So you can see these are all grouped. It understands what's similar. Okay, we'll rationalize this for you as part of the detailing process. Okay, you can see the shear walls there and all the detailing around the end zones. You can also see the beams here, and you can see that we are detailing all of this out. It knows what's similar. All the plastic hinge zones and so on will be appropriately detailed, and you can see even when you've got secondary beams coming in, additional links and so on will be provided for those. Okay, to collect those. So all the details here will be produced. Now, if a member gets if in the drawing sheet, maybe there's an example just here. A member's got a little bit too long for the sheet. It's truncated there and it's carried on with this above. So you can see it'll just continue. It'll try and optimize the placement of the beams within the drawing sheets for you. Okay. You are in CAD, so if you like to move any of these around, you can just come in and reposition them to suit. If you want to make other changes in here, you can do this. So if I decided, for example, that I wanted to cut this member and reposition this below. Okay, so all of this you can do. It's repeated the label. It knows the link spacing. Or there's intelligent drafting in here to allow you to manipulate the details to suit what you want to show. You can also show things in schedules. So if you just want to simplify the process, you don't want to provide all the level of detailing, you can show things in tabular schedule forms here as well. And this goes right down to the foundation. So you can see your pad footings here. You can also see your pile caps. Everything that we create here is being detailed out into the drawings. Now you can, obviously we can see all these drawings complete in this manner. You can create new sheets, and you can choose to selectively draw up what you'd like to see. So if I just wanted to draw up, for example, a shear wall up the entire building, I can just come and choose to draw this out. So that was the wall that we created earlier with the openings in it. So I can draw the whole elevation if I wish. You could just grab a particular beam and draw that out if you like. You also have the ability to be able to create your own details in here. So as I was mentioning, it is a complete CAD system, and you can in here, if you want to create additional details, you can do that. We have rebar libraries in here that you can take advantage of, and you can come in and draw out and place rebar into various elements that you might want to create, like I've done here. Okay. Now, if this was maybe it's a variation on a job, you can select all of this. Okay, and you can actually just instantly quantify this. Okay, and it will take all the rebar there. And instantly create a full schedule. You can see that there's 2.87 tons of steel there. That includes everything, all the laps, the links, including that little detail that we just created. So if you're wanting to compare different schemes, quickly evaluate different schemes on projects, you can. Any of these tables that we create, you are able to export these out to Excel. You'll see all the bar bending schedules being created there as well. Okay, and if you wanted to, in here, maybe you want to put in costs and so on, you can. Okay, so it's very easy to create and work in here. This is a full CAD environment, but you also have the ability to be able to cost everything out, provide all that additional level of insight. Now, we do have libraries here of other component design that you may want to take advantage of, so as well as a detailed library. I won't go into this into too much detail, but if you wanted to, for example, quickly design a staircase, you can key in the parameters here, you can design it. Okay, we will create the design report for it, so we'll do the various checks to the code. Okay, and it will document these. And but the key thing is that we are then creating the drawings. So these are design detail components in here, and the library's growing all the time. We've got retaining walls and scaffolding and core bells and pools, swimming pools and pile design. So there's a range of different design macros that you can take advantage of here. But the key thing with this is that we automate the drafting, we lay it all into your sheets, we arrange and create all the drawings for you here. Okay, everything's being set up in CAD. It's a DWG format, so any of these drawings you're able to send out. You can manipulate them in here, of course. You can do extra drafting in here, but if you'd like to at any point just send this out to CAD, then you can do that in here. Okay, so I guess the final thing I'm going to touch on, and then I think we've probably had enough, is that there are reports. So at the end of the job, we have a report manager. Okay, all the design documentation that we've done during the course of creating this project will be saved away into the report manager. Okay, and then we can take the reports that we've created and we can add them into one document. So I can just add all available. Okay, you can see all the reports here. Okay, and we can then combine these into one report. Okay, which you can then use for submission. This can be customized. You can put your company logo in here, make it look exactly like your calculation pad. Okay, and we will just bring all this all together into one document. You can add other information from maybe you've got site photographs, or maybe you've got a design brief that you'd like to incorporate in here as well. All this can be combined into the one. Just give it a second. Okay, it's not just bringing those elements together, but what it's also doing is in a smart way, it's creating all the table of contents as well. So just give it a second and it should spring to life, and then we'll be able to see it. So you can see all the table of contents has been automatically created here, and you can flick through and look at different aspects of the report. Okay, you know, all the seismic checks that we're doing, various detailed checks that we're performing. Okay, the BIM design calculations. So these can all be compiled into just one document. You can PDF this or send it to Word. As I mentioned, this can be customized with your logo, look exactly like your company calculations here. Okay. So that gives you an idea. I know that I just cannot do justice to the system just in the short amount of time that we have today, but I hope I've given you some insight into the platform. And I hope you enjoyed that. I'm just going to finish with a few, a few quick slides. So all of this system is supported by a very comprehensive help center. We now have a chatbot in there as well. So there's a little AI chatbot that you can ask it questions. There's comprehensive learning hub as well. We also have written a lot of white papers, and you'll see that there's a lot of white papers that have been written to substantiate the Indian standard. So you'll see various calculations that we've performed in there. We also have a fantastic YouTube channel, so check that out. There's lots of informative videos in there on various topics that we cover within the system that you can refer to. I would also, just to finish, I would just like to say, reach out to us and contact us through our distributor, CUS, who's been very supportive of us in India, and their contact details are here. I believe that some of them have been speaking to you already. And there are some very special offers as part of Diwali. We've got a very, very special offer. I can assure you that this is an offer that we do not entertain in other markets. So just as we're getting moving in India, we've got some very special offers to help you take advantage of the technology. So if you're interested in that, reach out to the guys. I'm sure they'll talk to you. And they're also there to help support you with the implementation of the platform. You can also reach us through our social media channels, so LinkedIn, YouTube, Facebook, Instagram, and so on, and through our website, protasoftware.com.